And we're back. It's time to sort it out with Mr. Sort Out. All right, now here's an interesting one. This is maximum height of projectile from energy. So here we have a, let's say, soccer ball kicked at this initial velocity. We know the angle as well. So we want to know its maximum height. We want to know its kinetic energy to start, and then its kinetic energy at the highest point. So let's start to think about this. Using our projectiles knowledge, we can break that initial velocity into the two components, x and y. Then draw a picture here, and you'll notice that it's going to follow that parabola-shaped path. Then at the peak, the velocity will not be zero. The velocity in the y direction will be zero, but the velocity in the x direction will be something, because it's going to continue moving in that direction. So that velocity will actually be equal to the initial x component because there are no forces in the x direction to speed it up or slow it down. So whatever we find for that component, it will maintain that velocity in the x direction, and it will only have that at the top. All right, so in this problem, we want to know what is the kinetic energy initial. So for that, just 1/2 mv squared, and that is the initial velocity, the whole thing from the kick, not split into components, would be that initial velocity. Then at the peak, we can do 1/2 mv squared, but what is the v? It's the initial component in the x direction. So we'll be looking at that for the kinetic energy at this point right here. All right, then we want to find the maximum height. So this is where it gets a little interesting because we have kinetic energy at the bottom. Then at the top, we have both gravitational potential and we have kinetic energy because it's moving. So plug in our quantities for these. Use the subscripts for initial and final. Then let's try to rearrange and simplify a little bit. Mass cancels on both sides of the expression. Go ahead and multiply the whole thing by 2 to get rid of these halves. So what we can find is this. Then let's get delta y by itself on one side. So we subtracted this over, then we divided the whole thing by -1. So we get that. Then get delta y by itself, and this expression should be what you need for the maximum height. Pretty interesting. All right, so that's what you need for that one. Try it.